Good day, everyone. I'm Daniel, a PhD candidate from the Smart Construction Research Group. Today, I'm here to talk about a very intriguing and relevant topic, a corpus database for cybersecurity topic modeling in the construction industry. I'm working under the guidance of Professor Boha at the New York University Abu Dhabi. Moving on to the abstract of our study, we are well aware that we live in a digital era where every industry, including the construction industry, needs to prioritize cybersecurity. This requirement has become even more critical with the advent of Construction 4.0. Unfortunately, more than 65% of organizations within this industry have reported cyber incidents in the past year. Despite the urgency, only about 0.25% of the cybersecurity publications are dedicated to addressing these issues within the construction industry. To bridge this gap, we employed LDA topic modeling, a form of deep learning, to identify potential research directions. Our methodology led us to identify 8 key research topics, for which we have proposed an action plan. We hope our findings will prove beneficial to stakeholders and researchers, helping them address the cybersecurity challenges that the construction industry is currently facing. Firstly, let's dive into the introduction part. We're in the era of Construction 4.0, where digital technologies like digital twins, drones, and cloud computing enhance the speed, cost, and quality of construction projects. However, this shift brings critical cybersecurity concerns. Data breaches like the incidents at Australian Intelligence, Turner Construction, and others can disrupt operations and safety. Unique challenges in the construction industry include varying cybersecurity knowledge, frequent and scattered communications, and dynamic project nature. In our research, we synthesized online content, built a database from 6 sources, and used LDA topic modeling to pinpoint future cybersecurity research directions and propose action plans. The next section is our methodology. There are 6 main steps leading to the final purpose of topic modeling, during which 4 intermediate corpora are formed and stored. Let's dive into it. We collect raw documents from 6 resources with the keywords cyber and construction industry. The 6 sources are like news articles and blogs and LexisNexis database, academic peer-reviewed publications, books and book chapters, specifications and standards, and reports from companies. After the raw documents are collected, and then we create the raw sentences and put them into a list of sentences from all of the documents. And then from the sentences, we screen the high-quality sentences by keywords firstly. We created a list of 76 keywords to screen out related sentences. The keywords are like cyber, threat, vulnerable, internet, secure, and safe. Afterwards, we want to screen out the sentences that are having the high quality in semantics. So we use semantic screening for sentence relevance. We manually label 2,000 sentences to ensure their relevance, using 0 for exclusion and 1 for inclusion. The criteria were good format and direct relevance to construction or cybersecurity. Secondly, we utilized 10 traditional machine learning algorithms for baseline comparison, using a lemmatized version of our second corpus to create a TF-IDF features. Thirdly, we trained and tested a BERT classifier using Hugging Face's Transformers library. We experimented with different hyperparameters and configurations using a training set and a test set. Lastly, we compared the performance of the totally 11 models, including the BERT classifier and the traditional machine learning algorithms. The model with the highest test performance were selected, and the sentences screened for inclusion formed our third corpus. We then used lemmatization on corpus 3, simplifying words while maintaining information quality. This was done via a custom Python script. Next, we applied latent LDA topic modeling. We experimented with varying number of topics based on coherence and perplexity scores. Our experiment determined 8 as the optimal number of topics. Let's dive into the experiments and results. This is a detailed breakdown of the raw documents, which is our corpus 1. The table is the performance of the BERT classifier, and the figure shows the performance of the traditional machine learning algorithms. We can see that BERT classifier achieved the highest accuracy of 0.903 at epoch 7 and 9, which is higher than the best accuracy of the machine learning algorithms. So we used the BERT classifier under the best accuracy performance to label all sentences in corpus 2, resulting in the creation of corpus 3. And sentences with probabilities under 0.5 are excluded, and the results show that 90% of the final sentences have probability over 0.85, which means that the BERT classifier is better. This is a breakdown of the 4 corpora that we have formed during the whole process. The figure shows the perplexity score and coherence score with the different number of topics that we try. And 3 candidate input variables, 8, 15, and 30, reach a peak respectively in the fluctuating line, as you can see in the figure. And then we choose 8 as the number of topics finally, as it results in more focused topics. The final number of topics derived is A, thus, with the perplexity and coherence score. The figure is a visualization of the 2D mapping of the 8 topics. They are grouped into clusters based on correlation. As you can see, topics 1, 2, 3, and 8 are closely related. Topics 4, 5, 7, and 6 are more independent with each other. As for the topic relevance, the bubble size represents the prevalence. As you can see, topics 1, 2, and 3 are more relevant, so they are the priority topics. Now it's time to summarize the topics into text. For summarizing the topic, for each topic, we have 2 references, that is the 10 keywords with the highest weights and the 3 most meaningful sentences out of a pool of 10 sentences with the highest contribution percentage. These are all given by the LDA model. For example, for the first topic, the top 10 keywords with highest weights were as following, as here you can see on the left, and the 3 most meaningful sentences out of the pool of 10 sentences are here, as you can see, and then we summarize the topic into the increased awareness of construction firms by providing training and contact periodic risk analysis. Follow the same process, we summarize the 8 topics, and each topic has we propose an action plan to deal with it. Based on the topic prevalence, we recommend prioritizing research on risk analysis and specific solutions to threats such as ransomware corresponding to topics 1, 2, and 3. And this table can serve as a reference for future research directions in cybersecurity and construction industry. Now let's talk about the conclusion and outlooks. To conclude, we use topic modeling to identify cybersecurity research areas in construction. Our corpus consisted of 66,000 sentences from 6 sources, and we determined the optimal number of topics to be 8 using LDA topic modeling. For each topic, we have proposed actionable steps. However, we acknowledge limitations. Our corpus contained irregular captures due to a focus on meaning over format, and limited existing studies on construction cybersecurity also affected corpus comprehensiveness. Looking ahead, we plan to update with new corpora and believe our refined corpus could train large language models, something like the GPT. Such models could power question and answering systems for cybersecurity consultation and management. Thanks for listening, and welcome if you have any comments or suggestions.